disease or a virus, but vaccines are things that prevent you from catching it in the first place. How do vaccines work? Humans are susceptible to many different types of diseases, and to fight these off, our immune system produces something called antibodies. These antibodies are targeted towards each specific disease that they are sent to capture information from, and they essentially store information relating to how the virus reproduces, how it plans to attack our immune system, and how our immune system can eliminate the virus. So when after these antibodies are produced, eventually our immune system fights off the virus, and the next time that we get the virus again, there are already antibodies present, so that it will be easier for our immune system to fight it off again, and so on. So with vaccines, like I said, they're dead or weakened versions of the virus, and essentially our body thinks of these as a virus, so it produces antibodies when the vaccine is injected into our body. These antibodies, like I said, store information relating to the virus, and eventually, because it's a weakened or dead state, our body defeats the virus no matter how strong your immune system is. So for most people, the vaccine works. And eventually, once we get the actual virus, the full complete version, not the weakened state, there are already antibodies present so that we can fight it off and avoid being severely ill or even death in extreme cases. If we didn't have vaccines, then in the first case, in the first place, well, we would have this complete virus attacking our immune system, and essentially the fact is that our bodies would be overwhelmed with these symptoms, and we would fall severely ill, and like I said, die in extreme cases, which is why vaccines are really effective and they work well as well. Now, herd immunity is essentially an application of how we use vaccines in the world today with our population. Like I said, you might have heard it. You might have heard it being talked about on the news and on television, especially from this person right here. This is Dr. Anthony Fauci. He's got a pretty long name. I'll have a go at pronouncing it. Dr. Fauci is the director of the National Institute of Allergy and Infectious Diseases. He is also on the coronavirus task force for the American government, and he's advising the President Trump, on how they can mitigate the risk and manage the current pandemic. He's talked a lot in the past about herd immunity and how it essentially helps us stay immune as an entire population against these diseases. So what is herd immunity exactly? Well, it's a concept that if a certain percentage of the population is vaccinated, it will stop the infection from spreading to the people who are already vulnerable and have not yet received a vaccine. So it basically says that only a certain amount of the population needs to be vaccinated for the entire population to be thriving and immune to the disease. This essentially saves the government a lot of money to begin with, because we don't have to spend enough to vaccinate everyone straight away. And it also means that the viruses can quickly be halted as soon as organizations develop a vaccine, because they can easily start rolling them out and trying to vaccinate as many people as possible, which will eventually slow down the spread of the virus and stop it. Now, a question that's quite common with the concept of herd immunity is, well, how many people do actually need to be vaccinated in order for the entire population to be immune to the virus? Well, generally it depends on how infectious the particular virus is. So with COVID-19, we're estimating around 80% of the population that needs to be vaccinated because it's obviously it spreads very, very quickly. As we all know by now, it spreads through well, water droplets in the air, when you cough, when you sneeze, etc. But with viruses such as Ebola, the outbreak happened a few years ago. And with Ebola, it's really dangerous, but it doesn't actually spread that much. So we don't need to vaccinate a high percentage of the population. Now, we all know about vaccines today, but where did they come from in the past? How were vaccines developed? Well, it all started off in the 7th century when Buddhist monks had the idea of drinking snake venom to become immune to snake bites, and also an early strand of smallpox that was sort of prominent in that period. We'll go through smallpox in a bit because there's quite a few. Well, in the next thing, Edward Jenner, he developed a vaccine for smallpox, and cowpox is essentially just a sort of subset of smallpox in the sense that it comes from cows instead of generally to us. So yeah, in 1796, Edward Jenner finally developed an early version of the vaccine for specifically cowpox. And what he did was he took a boil from the cow's skin and cut it open. Inside there was pus, and he took the pus and he injected it into an 8-year-old boy. He specifically chose children because the cowpox vaccine is quite prominent in children, and it actually has quite severe symptoms. Something such as, well, it causes a very high fever, sort of like COVID-19. It causes a high fever. It also causes severe vomiting and nausea, amongst other things as well. Now, in 1796, despite Edward Jenner actually, developing like an early strand of vaccine, early form of vaccine, it wasn't actually mass rolled out and mass distributed until 2 years later, when a number of scientists worked together and did proper experiments instead of just injecting people. They actually did some experiments, and they took a sample of a larger group and eventually developed the first smallpox vaccine. Eventually, they also mass-produced it throughout the 18th and 19th century, and mankind finally eradicated the disease in 1979. In the next century, Louis Pasteur was a French biologist, and by the way, by now, there have been a lot of vaccines and diseases as well, which have been spreading throughout the entire world, especially in this era, sort of. There was quite a lot of migration, especially with exploration and the founding of new lands, which caused a lot of diseases to be spread around, and this was why people needed to develop vaccines. So back to Louis Pasteur, he was a French biologist who discovered the vaccine for cholera and anthrax. Cholera is essentially so you have it also causes quite severe symptoms. Essentially, you get severe boils on your skin, and it causes conjunctivitis in the cornea of the eye, and as well as fevers and the sort of standard for symptoms. Anthrax is similar to that. It causes severe vomiting and diarrhea as well. So Louis Pasteur developed the vaccines for these, and they were also mass-produced throughout the 20th century. Moving on now to 100 years later, when there turns out actually over these 100 years, there turns out to be many different vaccines developed by many scientists around the world. And in the 1970s, people started to do protests, and there was a lot of movement against the idea of vaccines, why they weren't working, why they're not good for you. We'll go into that in a bit. But yeah, so there happened to be a lot of regulation against vaccine manufacturers, and this actually meant that the companies were essentially bankrupt, and they had to close down their factories, they had to stop manufacturing vaccines, and that meant that there was a decrease in the number of people who were vaccinated. But apart from all this, during the 80s and 90s, in the last few decades as well, we've had vast improvements in the field of genetics and vaccine creation. This has essentially meant that we've been able to find and develop new vaccine delivery systems. Vaccine delivery systems are basically like when you find ways of giving the vaccine to people, and they have different benefits, such as they're easy to make, they cost less, and they work more effectively, giving a higher dose of, or like a more efficient dose of the vaccine to the people. Despite all of this improvement and technological advancement, there's still anti-vaccination groups active to this day. So anti-vaccination, I googled the posh word for it, and they said it was vaccine hesitancy. And vaccine hesitancy is identified as one of the top 10 global threats of 2019, according to a UN report released earlier that year. It's estimated that around 1.5 million deaths are directly caused by anti-vaccination, people refusing to take vaccines, because essentially that means that the viruses are able to spread and cause symptoms, and therefore mean that people die. Despite this, though, there have been multiple studies to show that vaccines actually do work, and many organizations around the world do support the creation of vaccines, and the majority of people do take vaccines in the end. But anti-vaccination as a whole arises from, well, it comes due to a variety of reasons. And if you look into history, the main root for these protests, this belief, was because of ethical issues related to vaccines, because people just didn't believe that they worked, and they just didn't see any effects of vaccines. But among that, there's many other reasons, like some people are against vaccines due to their religion, and they have certain beliefs against vaccines. But although I found this to be it's quite weird, because the main religions, such as, well, Christianity, Hinduism, Sikhism, Judaism, they don't actually condemn the use of vaccines. But I guess some of the smaller religions do have this belief. Some people also believe that vaccines cause autism. This was quite prominent in around 2018 time, when there was a lot of circulation about these rumors on social media and on other blogging websites, when people thought and claimed that they had developed autism from taking vaccines. Because of this, there were parents refusing to vaccinate their kids, and that also contributed to the 1.5 million deaths due to not taking vaccines. Apart from that, well, some people are naturally just against the government, and they just don't agree with policies, they don't agree with taxes, they don't agree with, generally all the laws that the government follows and encourages. So it just follows that they won't take vaccines. It just follows that they won't take vaccines as well. But the main cause of anti-vaccination is that it causes an increase in the infection rate of the diseases that should have been eradicated a long time ago. It's pretty saddening to see that, for example, measles is a disease that has had a vaccine since 1963, but in 2019 the United States government reported 600 cases of this quite deadly virus. although it should have been eradicated a long time ago, because people weren't taking vaccines, it's still around today. I have read about this article that said, I think it was in 2019, that said that there was a measles outbreak in Disneyland, and that caused many people around that region to be, infected with measles. But that shouldn't have happened because, well, there's been a vaccine since 1963. This was also the same thing, a similar thing happened with the whooping cough as well, with there being a vaccine quite a long time ago, but it's still around today. So anti-vaccination as a whole is a movement that is quite recent. It's around today and it affects many people around the world, leading to more deaths. As I accidentally clicked on here, this is a subreddit that I found a few days ago. It's based around anti-vaccination and what people basically like people's ideas about not taking vaccines. So it just proves that it's all very real and it does exist around the world. Some people are even refusing to take a vaccine for COVID-19 when it comes out, which is just going to cause more protests, and it's just going to cause more deaths eventually because people refuse to take vaccines. So yeah, where are we with a vaccine for COVID-19? Well, as we all know, it's been around since December 2019, and many organizations are working to push the development of vaccines. In fact, so it's over 250 different organizations all over the world are trying to develop vaccines. 50 of these organizations are in the human trial stage, and we'll go through these. We'll go through the different phases for developing vaccines later on. So 50 are in the human trial stage, which is the stage just before they have to distribute it. And McKinsey, a global consulting firm, said in a recent report that the vaccine for COVID-19 will be available by late 2020, hopefully, or early 2021. It's not too far away, but there's predicted to be around 1 billion doses distributed by the end of 2020. So hopefully herd immunity can kick in soon enough, which means that most of the population will be immune to the virus, even if we don't have the vaccine. So yeah, what are the phases for vaccine development? Well, there's 4 stages that each organization has to go through if they want to develop a vaccine, and these is that having this standard procedure essentially means that we can ensure that the vaccine is safe, first of all, that it follows regulations, and that it works in the end. So phase 1, this is when the organization carries out initial testing. So they essentially take two or more subgroups of people, volunteers, healthy volunteers. One is given the vaccine and the other is given what we call a placebo. If you guys have done practicals at school, then we essentially will have used a placebo in our practicals. It's essentially when you set up a control group that observes effects which are present even if we haven't changed any of the variables, or in this case, even if we haven't given a vaccine, there are still effects that we can observe which are still present. And yeah, so these 2 groups are, one's given a vaccine, one's given a placebo, and scientists monitor they monitor quite a few things. First of all, antibody production and other response mechanisms such as how your body specifically reacts to the virus, how long it takes for it to react, and how many antibodies are actually produced so that it can counteract the virus. I'm moving into phase 2 now. This is when we're confident that the vaccine works, and we hope to eventually distribute it to the wider world. So in this phase, scientists introduce people of different ethnicities, people from different diversities, and we essentially hope to find if there are any effects of the vaccine on people that are different and people that have perhaps weak immune systems, like the elderly, like it says. Yeah, so we essentially test wider subgroups, seeing if the vaccine actually has an effect on everyone, not just a small set of healthy individuals, like in phase 1. Moving into phase 3, this is, like I said, this is where 50 of the organizations that are currently developing vaccine are in this phase right now. This is just before rolling out to the general public. Organizations essentially continue to test for immunogenicity and also if there are any side effects of the vaccine. Immunogenicity is basically it's a study of your body's response to a virus, so how your body specifically responds to the virus. And they went through that in phase 1. They attempt to check it with the wider subgroups from phase 2 and see if there is any difference in people's immunogenicities, along with the side effects of the vaccine as well. This phase is also dedicated to seeing if the vaccine works for, it complies with regulations. If you're an organization in the United States, you have to report to the FDA, the Food and Drug Administration, to make sure that your drug is actually compliant with their regulations and that it follows their rules. Basically, they have like an entire report of rules which organizations have to follow if they actually want to bring out their vaccines to the wider world. Now, after phase 3, hopefully, if the vaccines do get approved, then they're rolled out to the general public, and phase 4 is after that stage. So phase 4 monitors how the general public is responding to the vaccine and how the vaccine works in the long term, essentially, how if it wears off, how long it takes for it to wear off, as well as if there are any new strands of the virus coming out, because if there are new strands, then the scientists have to go through this entire process to make sure that the vaccine works for the new strand of the virus as well. So yeah, these are the phases of vaccine development. Like I said, 50 of our organizations are currently in phase 3, but and the rest are phase 2, 1, some are even before that. They're just trying to get funding for vaccines. Hopefully we will have a vaccine for COVID-19 by the end of 2020, if not maybe around January, February of 2021. So yeah, that's basically been my PowerPoint. To summarize, we've learnt about what vaccines are, how they work, the concept of herd immunity, and how this links with anti-vax. We've also learnt about a short history of vaccines, how we got to where we are today with regards to vaccine production, whether we will have a vaccine for COVID-19 and how long it will take us, as well as phases that organizations have to go through if they do want to bring out a vaccine. So thank you very much for listening to this presentation. I look forward to any questions you have. Yeah, so that's it. If we open up the chat, then I'll start by answering some of the questions.
Yep, excellent presentation, Aryan, well done. Guys, please jump in. The chat is open. You can ask questions via chat, or you can obviously chime in. Any takers? There is a bigger...
There's a bigger subreddit called Forced Vaccine that's more active than anti-vax. Well, maybe there is. I found quite a few. I thought to include one that just picks one out of them, to be honest. How many followers does it have?
Anti-vax. Okay. Guys, you can chime in as well. You can ask questions.
Oh yeah, feel free to unmute if you want to.
Unmute and ask. Pranav, thanks for the talk. Do you think that if anti-vaccination didn't exist, then COVID-19 wouldn't be a pandemic?
Hi Pranav, thank you for your question. That's a good question, to be honest. Do I think that if anti-vaccination didn't exist, COVID-19 wouldn't be a pandemic? Well, I personally, I don't think that COVID-19 was caused by anti-vaccination. I just think it's going to be worse because of anti-vaccination. So I think COVID-19 was just caused because of a certain like different species came together and a few mutations happened, and then the virus was caused. But anti-vaccination is essentially just going to take that and turn it into a multiplier effect, which causes more deaths, which should be, frankly, should be prevented. Yeah, anti-vaccination affects the status, yeah, of the COVID-19.
Hey Aryan, I have a question. You know they're talking about plasma being used to transmit vaccines for COVID-19. Have you done any research on that? Do you have any observations, or can you explain that to me?
There is this theory, isn't it, that they're using plasma to transmit vaccines. I think it's working. Some of the organizations are trying. I can't remember off the top of my head which ones they were, but they are actually using that to see if vaccines work, and they do actually work when you transmit plasma. Personally, I think that it could work because it's essentially taking your nutrients and you're putting a vaccine into it from someone who's actually like immune to the virus into someone who isn't, which is just going to strengthen their immune system. So yeah.
That's good. That's good. There are a couple of questions that have come in. One from Mehul. What an amazing talk. Do you know where anthrax began?
Anthrax? No, I don't actually. No, I don't. Not off the top of my head, sorry.
Okay, so Pranav, the presentation did not actually say 1914, 1904. All right, so Bhavin is asking, no.
Okay.
He says, no, sorry. Bhavin is asking, since each country has different ethnic groups and immunity systems, wouldn't we need more than one vaccine, since a vaccine developed by a country would mostly be adapted to that country's immune systems?
Well, that's a interesting thought, because it's true that different countries would have different immune systems because of their ethnicity, but I think that vaccines in general are widespread enough to cover the entire human race. And it's like I said, in phase 2 of if you want to bring out a vaccine, in phase 2 you do test it on wider subgroups, and most of the time that would be people from different countries. So I think that would be factored in when developing vaccine.
All right, so Pranav is correcting himself and suggesting that vaccine for anthrax was developed in 1904. Is that what you mean, Pranav?
Oh, yeah, carry on.
Pranav, you can unmute and just say if that's what you're saying.
Yeah, that's what I meant, yeah.
All right.
Yeah, the vaccine for anthrax was developed in 1904, like the PowerPoint said. But I think if you're referring to Mehul's question, he says that, I think he says, when did it actually begin? So I don't know about that. But yeah, the vaccine was developed by Louis Pasteur in 1904. Yeah.
Okay. Excellent. Thanks, Pranav. Thanks. Aryan Mehul is saying, what is he saying? After someone has been vaccinated, is it possible to then take the vaccine out of their body? Why would you want to take the vaccine out? Well, anyways.
Eventually, I mean, the vaccine, I don't know if it's artificially possible to take it out, but eventually your body does defeat the vaccine. And reading the next question as well, mine says it's been can you explain why vaccines have different lifetimes? Well, that's because the rate at which your body actually gets rid of the vaccine differs. So different vaccines are different. Vaccines are essentially viruses. So the viruses are of different potency, and that's why your body takes different amount of time to get rid of them, and that's the lifetime of the vaccine. And referring back to Mihail, that is, to my knowledge, that's the only way to get out of their body.
Now, that's a good segue to your next question. Mayank is asking, why different?
Oh yeah, I just said that. So they, it basically depends on the potency of the vaccine, where your body gets rid of it.
Excellent. Thanks, Mayank. Bhavin has come back in with another question. The future of COVID-19 will still be more prevalent in other countries. Will we be using COVID vaccines as a travel vaccine in the future?
Thanks for your question, Bhavin. I think COVID-19, I think COVID-19 will definitely end up being a vaccine that most people take. Travel vaccines, I think, are in general more sort of for vaccines for viruses which are present in specific countries. Like if you go to different countries in Africa specifically, although Ebola is everywhere, if you go to different countries in Africa, Ebola is like something that's quite present in those countries, which is why you'd specifically take a vaccine for it if you are to travel to that country. First, because COVID-19 is sort of a global pandemic, I don't think it'll be necessary for a travel vaccine, but it's definitely something like one of the first vaccines that people would take if they just in general, if they were to go to the doctor and like get vaccinated.
Great answer. Thanks, Aryan. Mehul just checked. As it turns out, anthrax began in Egypt and Mesopotamia.
Oh, that's interesting. I heard anthrax was actually used as a biological weapon at some point as well. I don't know. Yeah.
Kushi,
so, yeah, awesome.
Before Kushi, Dhruv, you have a question.
Yeah, so Aryan, you were talking about people you were talking about vaccines being tested on people. So I was wondering, how do organizations decide who they're going to test it on, and whether there's like a body that decides who is allowed to, whether there are rights for people. Like I was wondering, do you have to volunteer or how does it work?
Well, generally, they have to be compliant. Well, like I said, in America, you have to be compliant with the FDA, and it has certain rules for you can't just take someone off the street and force them into the lab. But yeah, they do have volunteer programs where you sign up. First, they open it to everyone. You sign up, and then they consider you if they run medical checks on you. And eventually they just sort of, there's probably a team of scientists in the organization itself that decides out of the candidates from the results of the volunteer program.
So what happens if something goes wrong and somebody develops serious symptoms, or let's say COVID-19, and they die? So what happens then?
First of all, I think that's really rare, first of all. But yeah, if it does happen, then it's likely that the organization will have to fill out a lot of paperwork, first of all, and they will have to be, their program will be shut down by the overarching authority, definitely. And yeah, well, there's obviously a lot of implications of that. They probably won't be allowed to develop vaccines in the future, along with other drugs as well.
Great. Another question from Kushi. Thanks, Kushi, for asking the question. Many people say that COVID-19 is man-made. Could the vaccine possibly make the situation worse?
Well, many people are saying that the COVID-19 is man-made, that it was developed by scientists on purpose as a sort of weapon. I think that's what you're getting at. But the vaccine, I don't think it could make the situation worse. I mean, unless the vaccine is also designed to cause symptoms and be if the vaccine's like deliberately designed to be a weapon as well, if that's the case, then yeah, it could definitely make the situation worse. But I don't think that like having a normal vaccine will make the situation worse, especially if the scientists have considered it from all points of view, and if they've actually gone through the proper tests and trials to make sure that the vaccine actually works.
Awesome. Awesome. Any more questions? Guys, you can also unmute and ask a question.
Aryan, do you know any viruses which have been there for a long time now but don't have vaccines? So like, I think Parkinson's disease doesn't have a vaccine, but I'm not sure if that's a virus.
I don't know if Parkinson's disease is a virus, but I heard of well, I'm pretty sure HIV recently got a vaccine, didn't it? Because the guy that was in London that got vaccinated, but that was also around for a long time before it had a vaccine. So that's what I can think of on the top of my head. Don't know any others.
All right. Okay. Thanks.
Excellent stuff, guys. Excellent stuff, Aryan.
Thank you.
Last call for questions from anyone.
Guys, you can unmute if you want. All right. Okay.
All right, Mayank, as we are beginning to see with certain professions, will the job of chemical researchers and other related professions in this industry become obsolete with the increased reception of AI?
Well, good question. With AI, and especially the medical field, AI is it's a field that isn't going to be very easily replaced. But I think it's just a personal belief. I think AI is going to not replace, but come into the like sort of infiltrate, if you will, infiltrate the different industries, most of the industries around the world, and the medical science is definitely one of them because of AI being used to develop to create advances in molecular genetics, and especially if we refer to vaccines again, one of the ways of screening candidates through the volunteer program is through the use of AI to run medical testing and consider the patient history as well. So yeah, I think AI I don't think jobs will be lost because of it, but I think it's definitely going to be really significant in the industry as a whole.
Yeah, so maybe I can add a little bit more color to that. So AI,
yeah.
So chemical researcher, AI by definition is based on historical data, which is what all the algorithms are based on which they behave in a certain manner because in the past, things have happened in a certain way. AI picks that up and tries to replicate it and learn from it as we go along. If you take example of COVID-19, and if you have to build a vaccine for it, you will not be able to use AI just because it's a very new virus, hasn't existed in the past. You will need a human intervention. Obviously, there are certain elements that AI will be able to undertake, but not complete chemical research will be done by AI, simply because there's no history, and it has to be needs to be looked at afresh, and which is where humans will be needed. Will vaccine nationalism be an issue for when a vaccine comes out, since rich countries will reserve billions of doses, leaving poorer countries with second priority? How will vaccines be fairly distributed without only the rich countries getting first priority?
That's definitely going to be a problem in the future, in the very, very near future, I think, because especially with, like you said, larger countries taking all the doses and and the poorer countries suffering because of that. To fix it, I would just suggest there to be sort of an overarching body with members from all the governments, so that we can vote fairly and allocate fairly as well. World Health Organization is working to fix this and counteract it, ensuring that everyone gets fair treatment. It's not just like the doses go to the highest bidder, but yeah, that's definitely going to be a problem in the future.
Okay, Aryan, I have another question. China, they're blocking and breaking supply chain to some extent by stopping countries like India and other countries in Asia from exporting virus ingredients, the chemicals that they need, and also because India is one of the leading countries in terms of medical research,
Yeah.
pharmaceuticals. It's blocking India from creating the vaccines by not letting them get the necessary imports and stuff. So do you think that will have an impact on the COVID-19 research, the vaccine research?
Yeah, I think it definitely will because well, if you have countries like sabotaging other countries on purpose because they want to, I don't know. I think isn't it because is it because China wants to get reserve doses, or are they just doing it as sort of like a anti-India thing?
All right, that sounds good.
Oh, I was asking Drew if. Okay, never mind.
All right, that's excellent, Aryan. Thanks all. It's already quarter to 4, 45 minutes to the talk. We'll stop now, but well done, Aryan. Excellent stuff. We look forward to having another talk from you in a couple of weeks' time. The next talk that we'll be having is on the 6th by Dhruv on indices and asserts.
And Capricorn's constant.
Right, so we'll see you then. Thank you so much. Guys, please get in touch if you are also interested in doing some of the sort of presentations. This is really, really informative and excellent. Absolutely mine. Thanks for all the questions as well. And Khushi and Bhavin, Pranav, Mehul, and the guys who were quiet, please jump in and ask questions. That makes the session all the more worthwhile. I'm sure presenter doesn't mind it. They definitely would want you guys to jump in and ask questions. It's the fun part. That's the fun part. All right. Thanks, guys. We'll talk to you again. Aryan, very well done. Keep it up. We'll,
Thank you very much, everyone.
Thanks. Bye now.